No, it's more like how to keep your app more secure, not safe. Like Bruce Shire, God damn it, said security is not a is a process, not a product. So you cannot expect to follow a set path to security and just say, okay, it was done once, so I'm secure. I don't need to do anything else. And that's how I would like for you to treat this presentation. It's more like a journey to security and to explore the security and cybersecurity field, rather than a set path to become to have a secure application. In this presentation, I will be relying heavily on the Android platform, mostly because it's easy. It was easy for me to prepare for. But that doesn't mean that iOS is safe. I will present today only a fraction of the knowledge that is present in the cybersecurity field. So don't treat it as, like I said, an encyclopedia of knowledge about cybersecurity. This is just some part of it that I discovered during my journey. And of course, if you work with any sensitive data or anything that relies on users' private data, hire a specialist. Don't take anything that's being said on this presentation as a way to make your app secure in these cases. So we will be going through the OWASP mobile top 10 list, but not through all the items, mostly because I chose those interesting ones. I omitted some of the most boring ones. If you want, the full list will be available in the presentation, so you can always, there will be a link to the presentation, so you can always check this out yourself, and what I omitted. What is OWASP? God damn it, it's hard to mix sometimes my Polish language with English language. So OWASP is Open Worldwide Application Security Project. They were founded as a non-profit organization in 2001, and they provide different kind of data guides and tools about the cybersecurity, mostly security of software, so software security. And they have something called, like here, called Mobile Top 10. This is their list of what they think is the biggest threat to the mobile application today. This is the updated list for 2024. The previous list was from 2016, I believe. So we have some good knowledge about this and updated knowledge about the biggest threat for the mobile applications. Let's start with the first one. As you can see, the presentation will be a little bit broken sometimes. It's because of the Google Translate, so don't worry about this too much, but we can always do something about this later on. If some slide will be unreadable, I will just open the Polish slides and we will be good to go. Misuse of credentials, it's in case the mobile application doesn't properly manage credentials such as passwords or API keys. And the problem with that is that it's easy to use this information, to get our hands on this information and how to use it against us. Or not maybe against us, but we can use it to, for example, do some calls to the API that we are not supposed to and drive the cost to you instead of taking the cost for ourselves and paying for them. One of the example scenario that I came up with while working on this is we are releasing a mobile application, and as we love AI, we attach an open API secret key into the code, and we forget about this. So the attacker just downloads the API file, unpacks it, extracts our secrets, and then now they can just use our secret key to do HTTP calls to the OpenAI. We are paying for them. We might, even if we have a lot of users, paying users, we might not see this, and we will just be financing someone else's projects. Example scenario for V2 is that the mobile application saves the user login and password for remember me functionality. I actually had a hands-on experience with a project like this, so not ask me about it. And attack against access to the user's phone, extracts the login and password data. This isn't that simple to do as the first example, but it's still possible. And the problem with that is it doesn't attack us, it attacks the user, and if you are working in a place like the European Union, you can expect heavy fines if something like this happens, because it's your fault, not the user's fault, that their phone was stolen, and they can use this password and login. How to protect against misuse of credentials? You should assume that everything saved into the application code or even in the application files is probably public. Maybe not the files per se, mostly the codes. What you can do is rotate API keys when releasing a new version of the application. This helps you to maintain a bigger level of security, because each time you do a new build to the production, you will just essentially bring a new API key, and the previous one will be revoked, so they won't be able to take the previous key and use it. They will need to get the new key. The problem with this is you would need some way to make sure that your users are forced to update your application, because you can run into a situation where some user didn't download the update yet, and they cannot access the application anymore because you are depending on the connection, right? And instead of storing keys in the application, you can use secret managers like Google Secret Manager and AWS Secret Manager, etc. And a few words about secret managers. Secret managers are good because they support fast key rotation. You don't need to change anything in your application in order to change the key. You just need to go into probably some kind of console and just swap the key to a new one, and it will be propagated through all your devices. And secrets are loaded while the application is running, so it's a little bit trickier to get your hands on the API key when it's being sent through SSL channels with encryption. Yeah, and they cannot be extracted from code anymore. Oh, yeah, not this. So currently I found two libraries on pubdev that implements the connection to security managers. The first one is AWS Secret Manager API. The problem with this is a generated package. They just took the OpenAPI, not OpenAPI, OpenAPI Swagger, and just generated a package out of it. So it's not ideal, but it's always a solution. And the second one is GCP Secret Manager. The problem with that is we are talking about security here, and see this unverified uploader. So we don't know who this comes from. So I wouldn't recommend doing something like this to your application, especially if you are working with Secret Manager. The good thing is I did some digging, and the author of the second package is Cracow. He's a senior Flutter engineer at Very Good Ventures, and it's probably some kind of bug right now. When I was creating this presentation, the pubdev didn't reflect that change, because he changed the repositories from one to another, and probably that's why there is a problem with the verification. So I decided to check whether I, as a cybersecurity layman, I am able to read the secrets written in the application code. So it's always, you probably heard that you can always see the code that your app was compiled with, and you can go through it and see the secrets. But I really wanted to check this, if I can do that with my minimal knowledge about stuff like this. So I did some digging and created an application like this. We have a secret that we shouldn't see, and yeah, that's it, basically. And my files look like every other project. So we have an end file that stores the secret as a const string. and then we have a column that just displays it from the class. My idea was that I will reverse engineer the application up to some point. I will unzip the APK file, and I will try to find some kind of Dart code, and I will just go to the code and see what I can find there. So I found a tool called APK tool, and this is exactly what you can see here. Oh, it's a tool for reverse engineering Android APK files, and what it does is just you give it an APK file and it gives you something in return that is unpacked. So I went ahead, installed it, and I run this simple command apk to app release.apk, and you can see it printed me some bunch of things that I didn't understand, but no matter what, I just noticed that new folder appeared in the folder that I was working with. I did some digging and found out that I can see libapp.so and libflutter.so for different platforms. And if you don't know that, when compiling for Android, your Dart code is compiled into native ARM machine code or other specific machine code. The result of this complication is the SO files that contains both your app code and the Flutter engine. So that's why you can see there is a libflutter.so and libapp. This contains the Flutter engine, and this mostly contains your application. So next I wanted to find a way to run it, to see what's inside the SO files. So I found something like this, HXD viewer hex editor. I downloaded it and opened the file to see this kind of monstrosity. As you can see, there is the decoded text, but it doesn't really give us anything. But no matter what, I said, okay, let's go through the whole APK and see if I can find something useful. And after spending some time with it, I found this. As you can see, our secret is like this, right there. And I'm not saying that it will be easy to find something like this in the code, especially if you don't know what you are looking for. But for example, API keys always follow the same how do you call it?
Pattern?
Yeah, the same pattern. So you can search by pattern, and you will probably find something that resembles the API key. And well, that terrified me a little bit. So I did some more digging, and I enabled. I don't have slides for this, unfortunately, but I enabled the Flutter built-in obfuscation. And it looks like it hides it well enough that I wasn't able, as a layman, to find the secret anymore. I know that there is also a good package about working with this. It's called ENG, and it also supports obfuscation. And I can confirm that also when I'm using this package with obfuscate turned on, I'm not able to find it that easily. It's coded as a binary something, so it's not that easy for me to spot. So moving on, M2, insufficient supply chain security. It's a problem where your security vulnerabilities don't really lie in the application itself, but they can be introduced in the development or during the build time. For example, through third-party dependencies. Example scenario. At some point, someone updates a package from our ecosystem that we use and introduces malicious code to it. Our pubflex YAML allows for automatic library updates because we use the caret system. So if you don't know, the caret system in Dart works like this. If we have a caret in front of it, if the library changes the version of the second part or the third part, it can be automatically updated. It just can't go above the first one, the first number. So there is nothing to stop you from doing some change to the package, publishing it on the pubdev. There is no verification on the pubdev as of the contents of the package. So what you can do is just publish a new version with 1.2.34, and it will be next time someone runs Flutter pub-get, it will be automatically taken into the application. So how can you defend yourself from against it? So I spoke only about the third-party library, but there is other documented cases where someone working on the application or someone working on the code can introduce some malicious code for it. For example, it can be as simple as a simple backdoor to allow elevated privileges for a specific user, and it can be used against your application. So a code review is your first line of defense. Of course, you can pin dependencies, and I will talk about this a little bit more in a second. And you should be checking packages before updating and installing. There is a lot of traction in the Flutter community packages, and sometimes you can see even the shifts between different publishers. For example, some kind of company was working on a package for years, and then somebody else took it, and it's now Chinese-owned package, and you are not really sure what's going on with this package anymore. You see that the branches were rebased, so you don't have even the history of the commits, and now you are left thinking about, okay, did they introduce something that I shouldn't see because they rebased? And the next one is keeping the application built in environment secure, because this is the third scenario. It's not a third party, it's not the developer that is working on it, but the problem is you are building on CI/CD machine, and the company was attacked. They gained access to the CI/CD machines, and they introduced malicious code this way. The controversy about using the pinning dependencies is that, according to Flutter team, we should use the carrot system, and it's said in the best practices. But the problem is that you can face a situation like this. I don't know if you heard about this situation. Peace not war. Some developer introduced a change, another dependency on the package inside Node package, and what it did was infect all the computers of Russian citizens, and if they discover that the IP address is Russian-based, it would start encrypting the 4 drives. So yeah, something like this can happen. It all depends on the project and your level of paranoia. I would advise to at least be checking out the changes between versions to the packages that you are using in your application, especially if you are working with some kind of valuable data. But yeah, it's pretty hard to keep track of all the dependencies that you are using in your application. The other way you can do this is you have a big company and you are keeping all the code in-house, but that rarely happens in the Flutter world. So yeah, that's our options. The third one is insecure authentication or authorization. So the mobile application has gaps in the mechanism for identifying users or checking the permissions of users. Simple scenario is the mobile application sends information about the user role to the backend, and backend because based on that information it decides if the user should access some data or not. So you can just easily swap the role in the application, and you will gain access to some other parts of the application of the backend. Someone forgot to check if the endpoint provided to us whether the user if the user has access to has rights to receive the requested data. This is common mistake that can happen, but if you see something like this, you should probably speak up and inform the backend team that there is a vulnerability in the system. The third one is the app does not enforce a strong password, but instead allows for you to log in with a PIN. So 4 numbers, it's really easy to brute force your way through it. And I've seen application like this, so it's not a speculation.
A quick question about that.
Yeah?
What about the biometric verification?
Great question. So depending on the platform, the biometric is available for you, and you can use it, and it's secure. So the difference between using biometrics or using something you built is that the biometrics are using the security chips in your devices. So if the security chip is not compromised, your application data won't be compromised either. But then still don't, like for example, use it to decrypt the password of a user. Just keep some kind of long-lived token and get a new token from the backend when something like this happens. But yeah, great question. How to defend against it? So you shouldn't trust the user on the mobile application at all. If you are working on a backend and you are trusting the client, something is wrong. And you can see this in the game dev community, that they learned the hard way that if you trust the user, you'll see all kinds of cheaters in your games exploiting your systems, because they will just change the data that is being sent to the server. And if server accepts all the data that comes from the user, this will be a disaster. M5, unsecured communication. Your application communicates with the backend without a valid SSL certificate, or in some cases you can use SSL pinning for this case. And example scenario is that a user connected, just so you know, it's not that easy to use this vulnerability. The earlier ones are way easier. But let's say a user connected to the public Wi-Fi becomes a victim of a man-in-the-middle attack. So someone sets up a public Wi-Fi network. They connect to this network, and now the attacker can see all the traffic. And if you don't have SSL, they will be able to see all the information that the user is sending to your application. But even if you have SSL, they can do something that is being called, I don't remember exactly what, and they can change the server and change the DNS file, change the DNS server to their server, the hosted server, and they can use your domain to serve the application with some other server. For example, they own some kind of server that mimics your backend, and they can just reroute the traffic through this network to their server. But the problem is with that is they would need to be having a valid SSL certificate, and you can check if the SSL certificate is the one that you are expecting, and this is what SSL pinning is. So how to defend yourself? Do not save user login information on the device. This is an obvious one. Use authorization tokens that have defined lifespan. I've seen cases where the token is not expiring because it would be a trouble to refresh. Use SSL certificates from trusted sources. There is at least 120 trusted certificate authorities. So just choose one of them, not some shady third-party one, or don't issue yourself a certificate because it might not be the best case. And the fourth option is you can pin SSL certificates in the client application and reject the connection if the certificate presented by the service does not match the one assigned in the application. And a few words about SSL pinning. I've mostly talked about this already, but okay. So SSL pinning, as I said, allows you to tell our application what certificate they should expect from the server. The application then compares the SSL certificate that is provided by the server with the one saved in the memory, and if they don't match, you should just refuse the connection because something is wrong there. The problem with that is you can expect that if you don't update your internal SSL certificate in the application, if you rotate the certificate on the backend, the user won't be able to communicate with the server, so maybe use a secret manager with it, or something like this. And the other problems is that the certificate authorities are starting to rotate certificates more often, For example, let's encrypt only allows you to issue a 90 days certificate, so you need to have an option to rotate it quite regularly inside the application as well, if you are using SSL pinning. And it's not recommended to pin so-called root CA certificate. The root CA certificate is saying that all the domains, all the certificates from the specific provider are to be trusted. So it's not really what we are trying to achieve. We are trying to limit the pool of trusted certificates to a minimum. And SSL pinning can be bypassed by patching the application binaries. I've actually seen a great post about this where someone from the cybersecurity explains how to do it to a Flutter application. But it's really hard to exploit such a situation because you would need to patch the binary and inject this application with patched binary to the phone of the user that you want to attack. So it's not that simple, but it's doable, and you can use it for other cases, like for example exploring your backend capabilities. So you can just patch the binary and see all the communication that happens yourself without the next user. And SSL pinning in Flutter is really simple, and I want to show you how to introduce it to your code. The first case is into HTTP package. So what you need is an exported certificate in the form of .set or .pm file. You can always export it from your browser. You can just click on the certificate, you will see something like this, and a big button for export, and you will get a .crt or .pem file. And what you then do, what I'm doing here, as I created my own class that is creating the HTTP client. It does need to be a feature, and we are loading the certificate file. We are creating a new security context. This is a part of the HTTP package, and then we are setting the trusted certificate bytes to the bytes of this certificate that we have saved in our assets, and then we are just creating an IO client with HTTP client with the security context. The problem with that is this won't work on the web because we are using IO client. You would need to supplicate it for the JS version of the client in order to use it on the web. But this can be done in a few seconds. And then you can just create an HTTP client and you can just use it as normal. SSL pinning in Flutter, case 2, DIO. DIO? How do you spell it in English? So, same deal, my HTTP client, future DIO. We load the certificate, we create a DIO, and here is the HTTP client adapter. We are creating HTTP client from this adapter, so yeah, we are creating the security context, and we are setting the trusted certificate bytes to the certificate bytes. We are passing in the context, and we are done. We only accept a connection from one server. One thing, as you can see, I'm using the default constructor for, not the default one, but not named constructor for security context. There is a constructor called default, and it contains root CA certificates for all the known CA authorities. So, for example, for all the known, the biggest one. So, if you don't want to be able to communicate with anything else than your backend, it's always good to use the one with only the security context without using the root certificates. And then we use it like before. We just create a HTTP client and call a get. That's it. Yeah, like I said, both solutions will only work on Android and iOS, but you can just do a few changes here and there, and you will be able to make it work on web as well, and probably on desktop. But I just didn't do it because it would get complicated, and I wanted to keep it simple. Let's go to the number 6, insufficient privacy controls. The application does not sufficiently protect sensitive user data, which may lead to its leakage. And an example scenario is that to optimize the loading of the administration panel, caching of information about company employees displayed in the panel has been implemented, and the data is saved in an unsecured local database. Especially if you are using Flutter Web. I don't know if you ever tried to go to DevTools in your browser, and if you are using a database like unprotected Hive and with no encryption enabled, you can see that all the records in the local database. So that would probably be a big risk associated with that. How to defend yourself against it? You should only store the necessary data on the user phone, and if something doesn't have to be there, it's better to not have it there. It's better to have it on the back end. And you can always encrypt the data that you store on the user's phone and choose the solution that suits the type of the data stored. There is a bunch of good options for the local databases in Flutter, and most of them support a strong encryption, and that's great. And if you no longer need to keep some data, for example, you just need, let's say, location data from the last 7 days, but anything past this is not important to you, just delete it completely. If you don't need it, don't use it, and don't store it. Insufficient protection of the binary files. I was talking a little bit about this when I showed you how to decompile the application, but it can also be used in different scenarios. For example, like I said, you can just decompile the application, find the encoded API keys. You can find how to get to your hidden def menu in your application on production, and probably cause some havoc. And after the compilation, the attacker can extract, for example, your AI model that you embedded in your application. And this was the greatest deal in your application, and now it's useless because everybody knows it. How to can just buy the AI model from them and just use it in their own app. And you spend a lot of money on that, your investors' money probably. And how to defend yourself against it? Yeah, well, you really can't. You can't completely say that you can secure your application from tampering with the binary code, or even decompiling the code to some kind of dark code. You can only make life harder for people that are trying such things. For example, you can use obfuscation on different levels to keep them engaged for a little while longer. You can introduce additional security mechanism. For example, you can compare checksums of your code and on your backend, so they cannot communicate with the backend system if they don't present the correct checksum. And you can, but it's best not to store anything in your code that can be made public. That's the best case scenario. If you want to use obfuscation, iOS doesn't currently support any form of obfuscation. Android uses R8, previously known as ProGuard, and that has its own additional obfuscation. You can use it like Flutter build app bundle with a flag obfuscate, and it will just obfuscate your code a little bit more. Decompiling that is not impossible, but it's really crude. The problem with that is you probably need to write your own decompiler for that. They changed the definitions of some basics things in the Dart code quite regularly, and this breaks the previous decompiler, so you will need to work your way to the newest version, of course, if you are using the newest version. But there is nothing stopping you from downloading the older version of the application and checking this one with already made decompiler. There is two tools, of course. The full slide is broken, but there's two tools that I found that can help you. The first one is Data. This is a proper decompiler for Dart code, but this one is duplicated and no longer maintained. It works for some kind of specific version, but I couldn't find out which one exactly. And the second one is Flutter, and this is really interesting because it doesn't work like a decompiler. Instead, this is a modified version of the Flutter engine, and if you run your application through it, it will just dump information as it goes through your application. So, for example, when you click on some button, it will dump information about what's going on in the application to your console. And this one, as far as I know, works for all the versions of Flutter that you can find. And next one is unsecured data storage. The application either does not encrypt stored data, or the encryption is very weak. An example from life is that while I was researching this presentation, I plugged my phone into Android Studio. I just went through a little walk through my files, application files exactly. And as you know probably, there is a specific secured folder for all the application data. It's on the Android, I believe it's media or something like this, or data. And you can find that each application has a folder there. In one of the folders that I could access from the application that you can use to schedule an appointment with your doctor, I found they have something. There is an application that you can schedule an appointment with the doctor. There is a specific feature in this application that you can send some additional information to your doctor about your past illnesses and all your medication that you are taking. And I found a file, generated PDF file from exactly this feature in my on my phone, like I don't know, 9 months later or something like this. And I think that this shouldn't happen, because if I lost my phone and someone has a basic knowledge of how the Android works, you can take this file and probably find sometimes even some spicy stuff on someone and use it to blackmail someone. So of course I reported into to the company, but they didn't answer yet. Maybe they will at some point.
Do it publicly.
Yeah. They will just publish my file. How to defend against it? Use a database that uses a good encryption, and try not to keep sensitive data in your lab for too long. For example, good encryption was introduced in the ISO, but be aware that it's only available in the SQLite format. It doesn't support the IndexedDB yet, and it probably never will. Hive has encryption options, and it's based, I believe, on AES 256 or something like this. And you can use Flutter Secure Storage that uses Keychain and Secret Manager on Android. And you can use Realm that also supports encryption. Yeah, some trivia. Android platform from version 10 plus encrypts application files automatically. So files are all decrypted when user unblocks the device. For example, if you turn off your device and you turn it on, all the files are encrypted. As soon as you enter your PIN, they are being decrypted to be able to use. And iOS also encrypts files, but in the native API I found there is 4 different levels of protection. And some files can be decrypted when you start the phone and unlock it with your PIN. And some files are encrypted so that only when they need to be accessed they are decrypted. And I didn't really find out if any of these databases use this native mechanism on the iOS platform. And it's a little bit complicated because, for example, let's take ISA, they use Rust under the hood. So you would need to check if the Rust library that they are using for accessing the mobile device system, storage system, is using the correct permissions or not. So it's not that really to find out this information. Next thing, this is outside of the mobile top 10 from OWASP, but let's talk about root or jailbreak, a situation in which a user obtains administrator privileges on a device. And why is it dangerous? Because it may provide access to some files stored by the application. It's not really, it's not always a case, but it's sometimes it is a case. It can allow you to listen to application communication with the outside world. For example, let's take some kind of application that listens to the whole network calls, and you can even attach to the process itself and see what's going on there. You can always change the memory itself then, and it's really easy with root, and you can change the way that application reacts and modify it in real time. So even if you have some kind of guards in place, they can be bypassed by that in real time and in runtime. And can this be prevented? Yes, it can, but not really prevented, but you can detect that if the device that the user is using is rooted or is jailbreaked. There is a bunch of commercial and non-commercial solution for that. In case of the really Flutter applications, I found that there is a root jailbreak sniffer that you can use to see if you are running on an emulator. This is probably another way to bypass the Google Play verification process. You can check if you are running on an emulator, and then present a different application to them. I haven't tried it yet. But the problem with this is that, like they say on the pubdev page, sometimes there is a specific root hider on Android that can bypass this and can be seen as not rooted device. It's not that easy to work around this emulator, but yeah, it happens. The second package that I found pretty interesting is the app integrity checker. You can generate a checksum of your code, of your Dart code, or even your whole application in case of iOS. And for example, you can store a version of this checksum of this build or this particular build. You can store it on the backend, and you can compare them, and if they don't match, you just don't allow the application to connect to your backend anymore. And there is also a very interesting thing called Flutter Shark. This isn't really cybersecurity, but I'm going to show you how you can use it to choose some information. And cybersecurity is always about getting more information about the potential victim. So there is an application for Android called Flutter Shark, and if you don't know it, it will show you all the applications that are written in Dart language in the Flutter, and you can see the version of Flutter they use, the Dart version, and you can see all the packages that they use inside the application. So let's say you know about a problem inside one of those packages, you know how to exploit them, and then you just install a bunch of applications and see what you can find and how you can use it for your own game. I wasn't thinking that there is an option to hide this information from Flutter Shark, but when I was given this presentation in Łódź, I spoke with someone from Ninko that was working on the Credit Agricole application, and he couldn't answer how they did it, but they actually hidden the information about what packages they are using from the Flutter Shark. So it's pretty interesting. I didn't find a way to do it, but I will still need to do a little bit of research about this. And yeah, that leads me to the last question: how do you live with all this? How do you live with all this information that you can be attacked in a million ways? First, don't rush out and implement all of those things in your application right now. You probably won't need most of them. Second, if you work in a truly sensitive environment, you either already have or should have a specialist, a cybersecurity specialist. And you can always make a list of all the biggest threats that you think your application is, do a little bit of research and see what you can do with them. It's not that hard in most cases, and you can make your application a little bit more secure. and implement slowly such security layers that are appropriate to your project. And this is the funniest part. It translated the last part as it's over, yeah, it's over. The whole world is over. Sources, of course, there is a bunch of it, 21 to be exact, and let's stay in touch into the presentation. Thank you.